When most people look up at the moon, they see a naked gray rock floating in the middle of nowhere. And honestly, from this far away, that seems kind of fair. But that simplicity is a bit misleading. The moon is not a smooth, deserted sphere. In fact, it's a heavily marked surface that records billions of years of collisions, volcanic activity, and geological collapse. From Earth, our eyeballs just don't have high enough resolution to appreciate the details. The most visible features on the moon are the large dark plains spread across its surface. For hundreds of years, philosophers and early scientists called these regions lunar seas because they genuinely believed that they were looking at oceans, which, in hindsight, is a bold conclusion to draw from a blurry gray disk in the sky. As telescopes improved, we eventually learned what they truly are. These regions are called maria, and they are vast ballistic plains formed by ancient volcanic activity. When enormous asteroids struck the moon, they didn't just leave craters. They fractured the crust deep enough that molten rock from below could rise up and flood the impact basins. So, what looks like a calm, flat terrain is actually the frozen aftermath of planetary-scale impacts. Their darker appearance comes from the iron-rich minerals in the basalt, which absorbs more light than the surrounding highlands. And that contrast is what gives the moon its familiar face. Outside the maria, the rest of the moon is dominated by craters. They appear at every scale, from tiny pits barely visible through a telescope to enormous basins hundreds of kilometers wide. The reason for this is simple. The moon has no atmosphere. There's nothing to burn up incoming meteors and nothing to erode the damage afterwards. So every impact is preserved almost perfectly, like a frozen timestamp. Over billions of years, this has turned the lunar surface into a layered record of collisions. Even relatively fresh craters remain visible for immense stretches of time. One of the most striking examples is Tycho crater, or what I like to call it, the moon's butthole. It is geologically young, and its bright rays extend outwards across the surface from the streaks of material ejected during impact. Those rays gradually fade over time, but on the moon, fading over time still means millions of years. So, what we are seeing is essentially a relatively recent impact event, still dominating the landscape like it happened yesterday. The moon, in a sense, is a crater record. It is a chronological archive of everything that has passed through the Earth's neighborhood. The moon also has mountain ranges, but their origin is very different from Earth's. On Earth, mountains are typically formed through a slow tectonic process. This is plates colliding, pushing land upwards over millions of years. The moon, however, does not have active plate tectonics. Instead, its mountains are mostly the result of impact craters. A clear example is the Montes Apenninus, which forms part of the rim of the Imbrium Basin. That basin itself is one of the largest impact structures on the moon. When the impact occurred, it didn't just create a crater. It displaced and uplifted enormous sections of crust, forcing them upwards into a rough arc of mountains. So, the Apennines are not a mountain range in the traditional sense. They are essentially the structural debris of a planetary collision. Nearby, the Montes Alpes are cut through a long valley called the Valles Alpes. It stretches in a straight line through the terrain, almost as if the landscape was split open and never fully repaired. This combination of fractured terrain and crazy geometry gives the lunar highlands a very different character from the Earth's mountains. One of the strangest things about the moon is that we only ever see one side of it from Earth. The opposite hemisphere, known as the far side, remained completely hidden from humanity until spacecraft finally photographed it in the 1950s. And despite what Pink Floyd may have convinced people of, the far side is not permanently dark. It receives sunlight just like the near side. We simply never see it because the moon is tidally locked to the Earth. That locking happened because Earth's gravity gradually slowed the moon's rotation over millions of years until its rotation period matched its orbit. So, every time the moon circles Earth, it rotates exactly once, which is honestly kind of creepy when you think about it. The moon has basically been staring at Earth non-stop for billions of years, kind of like the guy who's watching you through your window as I speak. But the far side of the moon is not just hidden, it's also dramatically different. Unlike the near side, which is covered in large dark maria, the far side is dominated almost entirely by rugged highlands and dense crater fields. The surface looks rougher, brighter, and far more chaotic. For a long time, scientists wondered why the two hemispheres were so different. One major reason appears to be crust thickness. The far side has much thicker crust than the near side. So, when massive impacts fractured the moon long ago, magma on the far side had a harder time reaching the surface. As a result, the giant lava floods that formed the maria mostly occurred on the hemisphere facing Earth. So, the side we see every night is actually the smoother and more volcanically resurfaced half of the moon. Meanwhile, the far side preserves a more ancient and heavily battered landscape. Hidden within that battered terrain is one of the largest impact structures in the entire solar system, the South Pole, Aitken Basin. It stretches roughly 2,500 kilometers across. To put that into perspective, it's wider than most countries. The impact that created it was so violent that it may have exposed material from deep inside the moon's mantle. Some scientists consider it to be the best natural window into the moon's internal structure. So, while the near side gave humanity the familiar man on the moon, the far side feels much more alien, more untouched, less like something orbiting Earth, and more like a sacred relic drifting through space. From a distance, the moon looks simple, a smooth gray sphere hanging in the sky. But up close, it's something very different. It is a world where oceans were never oceans, mountains were built by collisions, and even the quiet regions are the result of ancient violence. And yet from Earth, it still appears calm, which might be the most deceptive thing about it.